two objects, M1 is 5 kg and M2 is 3 kg, are connected by a light string passing over a light frictionless pulley as shown in figure. The 5 kg object is released from rest at a point h is equal to 4 meters above the table. A. Determine the speed of each object when the two pass each other. B. Determine the speed of each object at the moment the 5 kg object hits the table. And then how much higher does the 3 kg object travel after the 5 kg object hits the table? Okay, we have all three kinematics questions here. And the first thing that we need to do is to find out the acceleration of this block, right? So we need to find out the acceleration here, and we need to do Newton's second law analysis on M1 and M2. And M1 here is 5 kg, and then M2 is 3 kg. So if you see it here, M1 is heavier than M2. So intuitively, we know the movement here is going downward for M1, right? Because it is heavier. And then M2 is lighter, so it will goes up like this, right? Then what can we do from here? Remember that we need to draw free body diagram at this M1 here. So let's just draw it here. So I will have weight number 1. And then we have the tension of the rope pulling this up. So I will have T here, right? And we can do Newton's second law analysis on block M1. So we'll have sigma F here is equal to the mass time acceleration. And the one that is positive is weight 1 here, because the direction of movements is this one. So I will have weight number 1. And then T is the opposing force. So I'll have minus T. And we are working on block M1. So the mass will be mass of 1 multiplied by the acceleration. Good. And weight number 1 here is M1 multiplied by G and then minus T, and that will equal to M1 multiplied by the acceleration. Good. But then M1 is 5 kg. So I have 5. G is 9.8. And then minus T, and that will equal to 5A. Right? And then let's move this to the right hand side. So I'll have T plus 5A, and that will equal to 5 times 9.8. And 5 times 9.8 is 49, I think. Yeah, 49. Good. That will be 49. And let's save this as equation number 1. And then what else that we need to do is we do similar thing but for M2. So it is barely on the table, so I just ignore the normal force that given by the table here, because it going to move up soon, right? So we will have this one here, the weight of M2. So I will have weight number 2, and it will goes up here by the tension of the rope, and it is the same rope, right? So I will have the same tension. So I will have T here. Good. However, we have different direction here. This going up, right? So the consequences is the T came first, right? So I will have sigma F is equal to mass times acceleration, and this T will goes up first. So I'll have T minus weight number 2, and that will equal to mass number 2 multiplied by the acceleration. Good. And then we will have T, weight number 2 is M2 multiplied by G, and that will equal to M2 multiplied by A. But then M2 here is 3 kg, right? So I'll have 3 multiplied by G, so I'll have 9.8, and that will equal to mass number 2, I will have 3A. And so we'll have T minus 3A, and that will equal to 3 times 9.8. And 3 times 9.8 is 29.4. Okay, so I have 29.4. And let's save this as equation number 2. But then we have two equations with two variables, right? We should be able to solve it for t at a. And let's do that using calculator here. Let's set this up as equation solver, which is number 5. Two variables is number 1. And let's plug in all the coefficients. So I'll have 1, 5, and then 49. Then we'll have 1 minus 3, and then 29.4. Good. So I will have T here is 36.75 Newton. So I'll have T is 36.75 Newton. And what is the acceleration? We will have the y value here, and that will equal to 2.45 meter over squared second. Good. And that acceleration will be important for solving question A, B, C, and D, right? So what is the question A asks? Determine the speed of each object when the two pass together. When the two pass together, it will goes down halfway and this will goes up halfway, right? So I will have this one here. That will equal to, if this is h, this has to be h over 2, right? But h over 2 is 4 over 2, and we will have 2 meters. So it has displacement of 2 meters, right? And so we can use this formula here. Vt squared is equal to V0 squared and then plus 2ay, right? And we are looking for this Vt. So I'll have Vt squared. And Vo squared is the initial velocity and it is released from rest. So I will have 0 there. So I have 0 squared and then plus 2 multiplied by the acceleration. So I'll have 2.45. And then multiplied by the displacement. And it is halfway, so I will have 2 meters here. Okay, so I will have V2 squared is equal to this number here. Or we can just take the square root of it, right? So I'll have 2 multiplied by 2.45. And then multiplied by 2. So we have our speed here when it is halfway. What is that? Let's use our calculator here. Square root of 2 times 2.45 multiplied by 2. And we'll have 3.13. 3.13, and the unit here will be meter over second. Good. And now let's answer question B. Determine the speed of each object at the moment the 5 kilogram object hits the table. Okay, so it goes full length here until here. So I will have the displacement here from here. That will be h, right? Full h, and that will equal to 4 meter. And we can just repeat this with this y change into 4 meter, right? And let's do exactly that. Vt squared is equal to Vo squared plus 2ay. So I will have Vt squared is equal to 0 squared plus 2 multiplied by 2.45 multiplied by 4. Or we can have Vt is equal to the square root of 2 times 2.45 multiplied by 4. And that will be, okay, let's clean this up. So we will have this one multiplied by 4, right? And that will be 4.43. So I'll have 4.43. And the unit here will be meter over second. Okay, but then question C, how much higher does the 3 kilogram object travel after the 5 kilogram object hits the table? So the second mass here will goes here, right, at the height of 4 meter, right? So I will have this one here is already 4 meter. But then when this hit the table, like this, it still has initial velocity, right? So I will have for question C, we have some initial velocity which is v0. But because they are moving together, we have this v0 is equal to this number here. So I'll have v0 that will equal to 4.43 meter per second. And eventually it will rest somewhere here, right? Before it goes down again. And the question is the displacement of this one here. So here we will have our Vt is equal to 0 here. So I'll have Vt is equal to 0 meter per second. And the only acceleration that works on this is not by the force of the system, but by gravity, right? So the acceleration here is equal to minus, because it is slowing down, so I'll have minus 9.8 meter over squared second. And we can do this formula all over again. So I will have Vt squared is equal to Vo squared plus 2Ay. Okay, but Vt is 0, so I have 0 squared. And then we'll have 4.43 also squared, and then plus 2 multiplied by minus 9.8 multiplied by y. Or we can isolate this for y. So we'll have y is equal to 4.43 squared divided by 2 multiplied by 9.8. And that will equal to, what is that? 4.43 squared divided by 2 multiplied by 9.8. And we will have 1 meter. So I have 1 meter here. Okay, so that is the answer for question A. This is the answer for question B. And this one is the answer for question C. And I think that's all for this problem. Thank you for watching and see you in the next video. Bye bye.